This is weVISION, and I'm Dan Hutcheson. For many years, the semiconductor industry has had a critical stumbling block. When you think about the cell phones you buy or the PC you have, inside it are the chips. And in order to make the chips, you have to have these masks. And the masks actually contain all the patterns that you layer to make a semiconductor work and build transistors and build all of the interconnect structures. And as we've made things smaller and smaller, we haven't been able to shrink the wavelength of the light that we print it with, which means we've had to go to all of these sub-resolution imaging. And to do that, we need new mask technology. We're going to be talking about that today. My guest, Aki Fujimura, who's chairman and CEO of D2S, has been on the front lines of this. They've got some really exciting new products that they've just introduced, and we'll be covering that. So welcome to the program.
Thank you.
So you've got this new product. It's called True Model.
True Mask
Excuse me, True Masks. Okay. So it's True Mask, but you also have your True Model, right?
And yes, True Model is the engine that drives True Mask MDP.
Okay. So tell me, what are some of the issues? You know, when I think of mask making, I think that it's, you know, all you're doing is printing rectangles with an E-beam. How's that changing?
That's a good way to characterize it. Yeah, E-beam is the way leading edge masks have always been written. And for the last 15 years or so, it's been using a technique called variable shape beam, where it's VSB for short. But the fundamental unit of writing is rectangle of E-beams. That's how you write. So every shape that you want to try to draw on a mask is broken down into these rectangles, and a collection of rectangles creates the shape on the mask.